Okay, so modular arithmetic got us to here.
Yep.
But modular arithmetic sort of stops here, unfortunately. So we need a different idea. So we have a product of two numbers that's a power of 3.
So a power of 3, so it'll be a multiple of 3, which means the digits will sum to be a multiple of 3.
Okay, that's one of the properties of powers of 3.
Well, it's odd.
It's odd. And that's, it's a product of two odd numbers here, so that's not a surprise. There's something else that powers of 3 have that's special, that no other numbers have other than powers of 3.
So they have like a formula that you can use to find them.
Well, think about ideas that you know about from number theory.
Powers of 3. The prime factor, they only use 3s.
Okay, they only have 3's as their prime factors. So this is a product of two numbers, and the product only has 3's as prime factors. So what does it mean about those numbers?
Well, these should only
have 3's.
be powers of 3.
Okay.
But it's impossible for both of them to even be multiples of 3.
Why?
Because you've got one less than a number and one more than a number.
Ah, okay.
So only one of those numbers is going to be a multiple of 3.
Okay.
So
at most, one of these numbers is a multiple. In fact, one of them will definitely be a multiple.
Yeah, and then, but then you have got a problem because one of them isn't going to be a multiple of 3, but that's going to contribute to this number, which only has powers of 3.
So that says that it's impossible because you've got a multiple of 3 and then some non-multiples of 3.
Uh-huh.
And multiplying together to be a power of 3, which is impossible. Because these are all positive integers.
But we did see it work for 2 squared minus 3 to the 1, and notice what happens here when you factor 2 squared minus 3 to the 1 this way, because x is now 1 here. You get 2 to the 1 minus 1, and you get 2 to the 1 plus 1. So
it's 0 it's 3 to the 0 times 3 to the 1.
Yeah, so that was the only case where it broke. But so we can see that for an even power of 3 greater than 2, we just showed that 2 to the 2x minus 3 to the y equals 1 can never happen using a difference of squares and prime factorization.
Cool.
Yeah. It's pretty neat.
Yeah.
Okay, now we have to approach the second one. 3 to the y minus 2 to the x. And where x, this is odd, so I'm going to write it as 2x plus 1 equals 1. Okay. All right. What do you think we can do here?
Well, we can't do the same difference of squares trick. Because we have an odd power of 2 now.
We have an odd power of 2, yep. But this time the 2 is being subtracted away.
Yeah.
Or we could try the same trick, but
Okay, what would the same trick get?
so you could do it with the power of 3.
Aha.
So you would have to switch these. So you have to do 3 to the y minus 1 is 2 to the 2x plus 1.
So 3 to the y minus 1 equals 2 to the 2x plus 1. Okay?
Okay.
Now what?
So you have to use the difference of squares, but with the 3 to the y.
Okay.
But we don't know if 3 to the y is an even. We don't know if y is even or not.
Alright, so let's split it into cases.
Alright,
So
if y is even, we can do this difference of squares.
And what happens?
And we get, so we get 3 to
Okay, if y is even, 3 to the y over 2 plus 1, 3 to the y over 2 minus 1 equals the power of 2. I'm just go back lazily, call this 2 to the x.
And then it's the same, so it turns into this case. It's the same scenario.
Well, it's a little more subtle.
Well, We know
Because
that,
these are both multiples of 2 now.
but only one of them
Is
can be a power of 2 unless it's one of the small cases we've done already.
Okay?
Like if y over 2 was 1, because then you've got, or y over 2, yeah, it's going to be 3 minus 1 and 3 plus 1.
Mm-hmm.
So those are both powers of 2, but if it's a large y, then it's impossible to do.
because the powers of 2 are more than 2 more than 2 away.
Okay, very
So,
good.
it doesn't work.
The powers of 2 are, larger powers of 2 are separated by more than 2, which is what
Yeah.
these are separated by. So
Mhm.
this doesn't work for powers of 2. So once you get above 3 squared minus 2 cubed, this no longer works.
Yeah.
Okay?
Alright.
So we're down to one case now where y is odd. We'll go to the next video.